So we've worked through graphing linear and nonlinear functions, and we've talked about how to tell by looking at a graph if something is linear or nonlinear. We said that word within a word, within linear we see line, and so anytime we have a straight line on a graph, our function is linear, and anytime it's not in a straight line, it is nonlinear. And so just kind of a reminder of those definitions. A linear was an equation whose solutions form a straight line on the coordinate plane. A nonlinear function is an equation whose solutions do not form a straight line on the coordinate plane. And it was really easy to tell when we had just graphs. We could see the curve here, which made it nonlinear. We could see the straight line here, which made this linear. Now we're going to be working on how to tell if an equation is linear just by looking at its equation. So we've got some equations down here, and what we're going to be determining is whether or not each equation is linear or nonlinear. And if it's not linear, we're going to tell why. So before we do that, we actually have to describe what makes an equation linear. And so one of the things that makes an equation linear is the equation is in one or two variables. We're talking about x and y here. And just as kind of a tip here, FYI, one variable equations make horizontal or vertical lines. So an example of a horizontal line would be y equals 3. An example of a vertical line would be x equals 1. And so what they're saying here is that you could have one variable, y equals and x equals, or you could have two variables, which is what we're going to really focus on down here, those ones where x and y are both part of the equation. It's also really important that the variables occur in separate terms, so that's what we're going to fill in. On that line, the variables occur in separate terms. That means you can't multiply them together. They can't be next to one another. They need to be in separate terms, either separated by an equation or an adding or subtracting sign. Not a multiplication or division. That would not be a separate term. Then each variable occurs only to the first power. So the variables cannot be written to the second or third powers, x and y. They have to be to the first power. Otherwise, it would be nonlinear. And we saw that when we graphed some of these nonlinear functions. Anytime we had x squared, it made this U shape. And we mentioned that anytime we would have x to the third power, it would make this squiggly shape here. So anytime that x isn't to the first power or y is not to the first power, it'll be nonlinear. So here's kind of in parentheses another little hint, meaning no exponents on any variable, and no variable can be an exponent. And then the last rule, if the equation is going to be a linear equation, is that the variable is not in the denominator of a fraction. So if an equation is linear, it will have one or two variables, x and y. The variables will occur in separate terms. Each variable will occur only to the first power, meaning no exponents on any variable, and no variable can be an exponent. And last, the variable is not in the denominator of a fraction. So determine whether each equation is linear or nonlinear. If not linear, state why. Y equals x minus 1. We have an equation with two variables, so the first part is satisfied. The variables occur in separate terms. They're separated by an equal sign, so that fulfills that requirement. Each variable occurs to the first power. Because there's no power, we assume they are already to the first power, so it satisfies number 3. The variable is not in the denominator of a fraction, which it's not. And so if all of these things are true, then we say that this equation is linear. The next equation that we have is 2x plus 3y equals 18. The equation has two variables, x and y. The variables occur in separate terms because they're divided by a plus symbol. The variables are only to the first power. Since there's no power listed, we assume it's to the first. and neither of those variables is in the denominator of a fraction, and so this equation is also a linear equation. What we mean by this is that if we plugged in values for x and made a table, that these points would all fall, the ordered pairs that resulted would all fall in a straight line. On this next equation, we have y equals x to the second power minus 9. There are two variables, x and y, so it fulfills the first requirement. The variables are in separate terms. X is separated from y using an equal sign, so they are two different terms. Each variable occurs only to the first power. While y is to the first power, x is to the second, and so it does not fulfill that, which means this one is nonlinear. This equation is nonlinear because the variable has an exponent. X is to the second power. And we talked about when we graphed some of those x squared functions, we said that x squared we should recognize x squared as nonlinear. In fact, we should recognize x squared as that U shape, that parabola shape, or an upside down parabola sometimes if we have a negative x squared. The next one is y equals 4x. The equation has two variables, x and y. They are in separate terms. They're separated by an equal sign. The variable occurs only to the first power, meaning no exponents on any variable. Well, neither variable has an exponent. And no variable can be an exponent. In this case, x is the exponent, and so this is also a nonlinear function because the variable is an exponent. So if we're following directions, we're determining linear or nonlinear, and if it's nonlinear, we're stating why it's not. So make sure that you're getting these reasons down in your notes. At this point, I would challenge you to pause the video and try these last four on your own, and then come back and see how you did. So hopefully you tried to describe these as linear and nonlinear, and if they were nonlinear, you tried to explain why. This next one, y equals 2x. I remember the last rule being the variable is not in the denominator. This variable is, so I know that this is nonlinear because there's a variable in the denominator. The next one, I have two variables, x and y. They occur in separate terms because y and x are separated by an equal sign. They're both occurring to the first power because they don't have an exponent otherwise. And the variable here is outside of the fraction. It's not in the denominator. So this y equals 2/3 x plus 5 is what we call a linear function or a linear equation. And it doesn't need an explanation if it's linear. The next one, xy equals 24. The equation has two variables, x and y. The variables do not occur in separate terms. X, y is one term because when they're being multiplied, they're considered one term. So this is a nonlinear function because the variables are not separate terms. If we tried to solve for one variable, x, y equals 24, and we tried to solve for x, we could divide both sides by y, and we would get x equals 24 over y. And then we'd have a variable in the denominator. So again, we're seeing why those terms have to be separate, or why those variables have to be in separate terms. Otherwise, you get a variable in the denominator, which we also know makes it nonlinear. And then this last one, we have two variables, x and y. They occur in separate terms because they're separated by an equation or a plus or minus sign. There are no exponents greater than the first power here, and the variable is not in a denominator, so this last one should be considered a linear equation or function. That means that no matter what numbers we plug in for x, when we make a table, our y values, our x and y coordinates will fall on a line, in the coordinate plane.